Yes, so good afternoon, everyone. I'm Aurélie Martin from the French Chamber of Commerce. Today, I'm very pleased to welcome our speaker from for this AfterLab tonight. We will have Francisco Sinesta and Dominique Bayarja for this talk about DesCartes program. Please note that this presentation will be recorded. If you have any question, ask your question in the chat box, and please mute your mic. This AfterLab is a joint initiative by CNRS, Ambassade de France, and French Chamber of Commerce. Thank you, and I pass over to you, Dominique.
Okay, thank you. Good afternoon. So my name is Dominique Bayarja. I'm the director of the CNRS representative office in ASEAN, and also the scientific executive director of CNRS at CREATE. So I will try to give you a very short overview of the CNRS representative office, of the presence of the CNRS in ASEAN, and in particular in Singapore. If I can, okay, what happened? Okay, so first I will start with the CNRS ASEAN overview. So just to give you this picture of where the CNRS is acting some research activity in ASEAN. You have some activity in Vietnam, Myanmar, and also, as you can see, in particular in Singapore. So this presence of the CNRS in Singapore can be detailed by this slide. We have what we call 4 international research labs. So these labs are on, maybe I can remove this, sorry. IPAL on artificial intelligence, Sintra, mainly dedicated to nanomaterials.
Do you have the location of those?
Majulab with more focus on quantum technology, and BMC2 on biomechanics. So these research international labs are joint lab between CNRS researcher or researcher from a French university located in Singapore full-time in collaboration with NUS, NTU, ESTA, for example. We have another type of collaboration in Singapore, what we call international research project. And we have several topics currently under progress, one on biosynthetic, one on materials and bioimaging. And this international research project, again, are collaborative project between French researcher and Singaporean researcher in Singapore. And we have also what we call international research networks. So we have one currently on energy and another one on social science. So this international research network are not only between France and Singapore, but in this case, between France and the ASEAN. So the last, based on this presence in Singapore of the academic research, we start in 2019 what we call CNRS at CREATE. So I will explain to you what is CNRS at CREATE. So because I think we don't have too much time. So this CNRS at CREATE is a subsidiary of the CNRS located at the CREATE campus of the NRF. So what is this CREATE campus? This research campus for research of excellence and technological enterprise, means CREATE, was created by NRF 10 years ago, more or less. And the objective is to generate international research between Singaporean researcher and international researcher. So currently in the CREATE network of this NRF, we have several foreign entity, foreign university like MIT, like ETH, Cambridge, etc. We have also Nanyang, the NTU and NUS from Singapore, and the last one, CNRS, which is the first organism within the CREATE campus, while the other partner are university. So this CNRS at CREATE, as I said before, was established in May 2019. It was inaugurated in June 2019, and I'm the director since September 2019. So what are the objectives of CNRS at CREATE? It's to generate a transcontinental research center with unique opportunities for students, staff, and researchers, a place to build and to conduct large research programs in some areas that are relevant to Singapore, social and economic needs. And CNRS at CREATE will act as a program operator to manage those research activities. And of course, we will work in close collaboration with IPAL, Sintra, Majulab, and BMC2, I mentioned previously. CNRS at CREATE will contribute to initiate and to define transdisciplinary research programs and projects related to the 10 divisions of the CNRS. I will mention them just after, with principal investigator from CNRS, French University, School of Engineers, and other French organisms, and of course, when possible, with other CREATE members. Just to remind you, the 10 institute or division from the CNRS. I don't go into details, but you can see that we can address many topics within the CNRS. Just to explain to you the three type of project we can have with CNRS at CREATE. The first level is the level of international interdisciplinary programs. That's the case for DesCartes that Paco Ginesta will present just after me. So for this kind of program, the duration is of 5 years. The estimated budget is around 10 to 25 million of Singapore dollars, and the PI have to spend minimum 1 year in Singapore, and the criteria to get this program are described here. They are based on the scientific excellence, of course, on disruptive and transdisciplinary research activities, high potential impact for Singapore, and in accordance with the strategy both of Singapore and the CNRS and French strategy. The second type of project are what we call intra-CREATE project. In this case, the duration is about 3 years, and the budget is around 1 to 5 million of Singapore dollars. There are 2 calls of this intra-CREATE per year, and the collaboration have to be at minimum between 2 CREATE partners doing that want to collaborate under this intra-CREATE project. In this case, the PI of the project have to spend minimum 7 months in Singapore. Then the last one is what we call seed-funded project. In this case, the duration of the project is 18 months, and the estimated budget is around a little bit more than $250. It's 250,000 Singapore dollars. We have 2 calls per year. And in this case, this kind of project is to generate new collaboration between two young researchers, PhD plus 8 years, and to give them the opportunity to be the PI of a project, of collaborative project, and to learn how to manage a project and to do research by themselves. Maybe I can split this one. And just to finish my presentation, today under CNRS at Create, we have we have now two intra-Create seed collaboration program. We have 4 intra-Create thematic grant program. One will be start next April, and we have DesCartes. And DesCartes is the first large program under CNRS at Create. This program, and Paco will explain after me, is based on intelligent modeling for decision making in critical urban system. I put here some key numbers of DesCartes. It's about the research budget is about 30 million. We have in this program 80 professor and permanent researcher, 100 years of research fellow, 30 PhD students, 50 years of engineers and lab assistants, and more than, let's say, 80 to 90% of the budget are dedicated to the fundamental research. So that's a research project on the use and the coupling and artificial intelligence and engineering. You have here the partners in this project with all the French partners. So CNRS, of course, and some university and school of engineers from France. We have 4 partners from Singapore, NTU, NUS, STAR, and SUSS. And we have 5 industrial partners in DesCartes. I don't go into to the other slide because Paco will explain to you what is DesCartes. My slides are available on the web if you want to keep them, and if you need more details on what is CNRS in ASEAN and what is CNRS at Create, don't hesitate to ask me by email. I will reply to you, of course. Thank you very much. Paco?
Yes, I will share my screen, but I have probably now, perfect. Can you hear me?
Yes.
Yes, yeah, we can hear you and we can see your screen. If you can
perfect.
just extend. Thank you.
Excellent, excellent. So I will present with some detail this DesCartes program. And in particular, I'm focusing on this kind of hybrid artificial intelligence that I summarize in this fact in the title of informing and augmented learning for empowering the engineering of critical urban systems. First of all, obviously, to thank the organizers for inviting me for this presentation. So we would like to focus a little bit later on this project, DesCartes, that everything is in the title. Intelligent modeling. This means we need to model complex system of systems. But the important thing is for decision making. And for decision making means we need to proceed very, very fast, in real time, instantaneously in some cases. And it applies in critical urban systems. And as these systems are critical, we need to make diagnosis and prognosis very, very accurately. So finally, we describe here the main aim of DesCartes is making very, very fast, making very, very well. And we are applying this in smart cities that finally is a system or a complex system of complex systems. So this is the main difficulty in modeling this kind of cities, in the sense that everything is interconnected and is a complex system that is composed of complex components. Obviously, if we are applying this in smart cities and we are applying artificial intelligence, we would like to address many systems, like appears in this slide, mobility, obviously by optimizing the traffic flows and smart parking, among many other applications, smart energy and buildings, in order to optimize the energy system forecasting, and obviously there is some keyword that is present, that is smart grids in digital energy or digital multi-energy. Another many applications related to safety, health and social security, and local government. For that, we need to apply many technologies. Obviously, you have in the top artificial intelligence and machine learning in order to transform the data in models in order to make projections, diagnosis, and prognosis. We need cloud technologies, we need communication, and we need that all the systems are interconnected. So all these technologies are needed in order to collect data and transfer this data in information and into knowledge, because finally from the knowledge that we will take the right decision at the right time. And the important thing is, in these systems, we are in system of systems that are very complex. And engineering in these scenarios is quite complex because the systems are very large and very uncertain. There is a lot of uncertainty, and in a city, you can imagine that we have the human in the loop, and the human is not easy to be modeled. We would like not only to design systems, we would like to learn from the functioning, we would like to monitor in order to anticipate, in order to make these three keywords that are in green: diagnosis, something is occurring; prognosis is trying to make a prediction in the future in order to take, obviously, the right decisions. And for all that, we need, as engineers, we need to proceed very fast is decision making, and be very accurate, because our systems are critical. And we need to conciliate definitively these two keywords in blue: accurate and fast. Obviously, this is not easy. In engineering, in physics, in the past, we had a paradigm that was all the models based on the knowledge based on the physics, is the part that appears in the top. You can imagine in this picture that appears on the right on the top, a real system that is symbolized by this continuous red line, and we have a model that represents it. And this model is the discontinuous red line. We can see that apparently the accuracy is not so bad, but obviously our model, our conception of the reality is not perfect. And there is a gap between the reality and the model that we are trying to use in order to describe this reality. Why there is a gap? Maybe because there is a lot of variability, is the words in red in the top part of the slide, because there is sometimes a lot of uncertainty. The reality is the reality, and our models are our models. And in general, the reality is a little bit much more complex than our model. Obviously, it takes a lot of time in order to compute these models, even if today the use of model order reduction can alleviate this difficulty. And the advantages of this approach is we can explain, because there is a lot of knowledge from centuries, and we can extrapolate even for any value of the data. As we are not happy with this paradigm, because there is a gap between the reality and our model, we could move to a fully database approach. That is the one that appears in the bottom. Here you have the reality, the continuous red line, and you have the measurements that you obtain, you collect the data that you collect, that are the blue dots. And you can see that in the place in which you are making measurements, the accuracy is quite good, is the accuracy of the sensor. But obviously in between, as you have not information, you put this discontinuous blue line, and obviously you have the tendency, but you have not the solution. Obviously, people explain, you need big data, take a lot of more data, and you will represent the reality. Yes, but in engineering, data is synonym of cost. And this means that having a large amount of data is very expensive. The other difficulty is, even if you can collect a lot of data and describe the reality, it's difficult to explain why this reality is in this way, because finally everything is based on the data and there is not a knowledge inside. The advantages, as appear in the keywords in green, this is quite accurate in the points in which you are making measurements, and this is quite general because you can apply this in any discipline. The hybrid paradigm that we are proposing is that the reality is the things that we know, and we are trying to enrich the models by making a model of the deviation, of the difference between the reality and our models. If you take this image on the right, you can see that now we have a model that is not perfect, but is quite close to the reality, and that the gap between them is more or less this continuous line that appears in the bottom in blue, this continuous blue line. And as is in this case quite linear, few points, few data suffice in order to obtain a model of the ignorance. And so finally, the reality is your model plus a model of the ignorance. The model is based on physics. The model of the ignorance is coming from the data and the artificial intelligence. And finally, we have these three paradigms that I summarize in this slide: the physics-based on the left, the data-driven in the middle, and the hybrid, in which we can see that the reality is the knowledge, like in this diagram, the physics, and the model of the ignorance that I represent by this neural network in order to represent this deviation. Obviously, in order to learn this deviation, we need to change the paradigm. And the idea is, in the past, is the left part of this slide, we have data, that is the inputs and the system. We have a model that is coming from the physics. We have mathematics in order to solve these models, and at the exit, we have the data in red that represents the response of the system. And we have now the new paradigm in artificial intelligence and machine learning that is on the right, in which you have the data that is coming. You know also the data, the result, the outcome of the process. And now the idea is, if I have the data, the input and the output data, can we identify the model? So before, the model was known, and the unknown was the result. And in this case, the input and the output are known, and we are looking for the model. And for that, instead of using the physics and mathematics, as in the case in the left part of the slide, we are applying artificial intelligence in order to obtain this model. And for that, there are many technologies. Some ones take the data and try to fit a polynomial, linear, non-linear, regularized, there are many variants, as all these technologies that appears in the top on the left. Now we can apply also neural networks that try to combine the inputs to generate an output in the same way that our neurons in our mind. And this is very usual in all the deep learning community. Obviously, all this is independent of the physics and the information that we know. And for that reason, there are now many hybrid artificial intelligence, like the ones that appears on the bottom. On the left, we are trying to inform the learning process about the things that the model should fulfill. For example, in mechanics, we need to ensure the conservation of the energy or the positive dissipation. And when you are introducing this in a neural network, you obtain something that is very popular today, the physics-informed neural networks, in which You are trying to create a regression based on neural networks, but you are enforcing a model, a partial differential equation, in order to introduce in this learning process all the things that you know. And if you know, it's not necessary to learn again. And with this, we can simulate very complex physics. I have no time to show this video because I would like to move on in the DesCartes program. The DesCartes program, as Dominic mentioned, was launched last January. You know a lot of information of this in the website. And in this program, there are three main components. The first one is intelligent computing. The second one is empowering people in a smart society. And the third one is engineering and a builder that we are creating in order to address all these challenges in an hybrid framework. So in this program, we have many specialists in many areas, some ones in artificial intelligence, engineering, humanities, data science, formal methods, signal and image processing, social science, natural language processing, and human-computer interaction. It's a very large program about the smart city, and we need all the competencies in order to reach this ambition. The builder, that is one of the main protagonists of this adventure, is something that is able to transform from the left to the right, collect data, smart data. Smart data means the right data at the right place at the right moment. And obviously take also into account, like in this orange rectangle, all the information, all the knowledge of all the models that are known on the physics that we are treating. And after we are trying to compare the data that we are collecting with the predictions that are coming from our models. And if we compare and the deviation is not zero, this means that we have an ignorance. The reality is much more richer than our conceptualization, that our models. And in that case, we need to take all this deviation and create, by using the technology that I just described, a model of the ignorance. And as soon as we have the knowledge and we have the model of the ignorance, we can combine both in this rectangle composed of two triangles of different colors that we call hybrid twin. It's a twin of the system, and it consists on all the components, all the models that are known on the physics that we are treating, plus a model of the ignorance of the difference. And as soon as we put both together, you remember the fundamental equation: reality is the things that I know plus the things that we ignore. As soon as we have model for the knowledge, a model for the ignorance, we have the hybrid twin. This hybrid twin is a real replica of the reality. And by using these predictions, we can use a controller in order to take decisions in a supervised or unsupervised way with respect to the human. And this is the builder that we are trying to elaborate in DesCartes, and we are trying to apply to three demonstrators. The first one concerns digital energy in collaboration with EDF, in which we have two paradigms on the left, one that is based on models, but the problem is there is a lot of uncertainty in the consumption of energy. And obviously, this approach takes time and is not very accurate. We could try to move to the left on the bottom and using something that is only based on data and artificial intelligence. But in that case, we need a large amount of data in order to understand everything, even the things that are critical or that occurs only sometimes in a life. So obviously, this is not the right direction, and the idea in our case is to proceed with this hybrid approach that I illustrate on the right, in which we have the models that are given the first predictions, and from the data, we try to check, we try to enrich, and as soon as we have or we put both together, we can control and we can adapt in a very efficient way. The second one concerns remote sensing that we are developing with CETIM and ESI group, in which we are trying to address very complex and large civil or industrial infrastructures in order to make monitoring, structural health monitoring, or non-destructive testing. But obviously these infrastructures are very, very large. We have not a lot of sensors, and so it's difficult to obtain the right data in the right place. And for that reason, we are trying to use drones. And by using a drone with a lot of sensors, we can check the different infrastructures, and in real time, we could have an indication about the state of the systems and the necessity of having something like predictive maintenance. Another one, more in the setting of civil infrastructures, you could try to check some parts in an infrastructure, and first you need to approach, you need to scan, you need to analyze all the information that you are collecting, you need to dialogue with this hybrid artificial intelligence in order to use the data. But as the data is not very rich, we are trying to use this data, but also all the models coming from the physics and the engineering. And at the end, you have a nice predictor of the reality. And finally, we are trying to develop another one about the mobility, and in particular in traffic management by using, again, drones. In this case, the industrial partners are AREA, ESI Group, and Thales. And the idea is how to planify optimal trajectories that are extremely impacted by the local environmental conditions. And obviously, we have not too much sensors, and we need to take the right decisions from field data. That is the data finally that is collected more or less by the drones during the flight. In order to prove these solutions, waiting for having access to virtual Singapore, we are trying to focus in this quarter of the La Défense in Paris. This is the geometrical model on the left. You have an image of the La Défense on the top on the right, and you have a mesh that we are using in order to describe this quarter, all the buildings and all the environment. And by using artificial intelligence, this means creating some simulations based on physics and trying to collect or to take all this data that is provided by these simulations, and using a regression, we can construct something like the wind map in a parametric way, because in this case, I show in the video, the velocity of the wind and the orientation of the wind with respect to the quarter could change. And as soon as we create the model, we can manipulate these facts in real time. You have here two buttons. With one, we are controlling the magnitude of the wind, and with the other, the orientation. And now, as soon as this is known, I could change any of these parameters and compute or predict in real time the evolution of the wind map. Here I'm changing the magnitude, increasing the velocity, and you can see that obviously the colors that represent the magnitude of the velocity is changing. And in this case, as you can see, I'm changing the orientation. And as soon as you choose your magnitude and your orientation, you have an accurate representation of the reality. Obviously, when you have wind in a very cloudy quarter, there is also a lot of turbulence, vorticity in the wind in the rear part of the buildings. And for that, again, we are trying to estimate not only the buildings, but also these parts of these regions in which there is a lot of vorticity, in order to avoid the drone flying inside. And we call it the excluded volume. And we need also a model that is able at the level of the city to, for a given magnitude and orientation of the wind, be able to identify in real time these regions in which the drone cannot fly. And again, we generate data, we learn from this data, and now in real time, you can again increase the magnitude, and you can see that the volume, the excluded volume, is increasing and increasing. And after, you can, here we are decreasing a little bit, and now we are changing by moving the orientation. And when you are changing the orientation of the wind, obviously the regions in which the vorticity is very high is also changing. But we can evaluate all this in real time. And for the reasons, if we are planning a flight from point A to point B, if the wind is in vertical, as you can see in the picture on the left, we have a plan. If it's changing to the horizontal direction, in real time, we are adapting the trajectory, and everything is made in real time. The wind identification, the creation of these regions, excluded volumes. For this reason, you can see that inside each one of these regions, there is a building, but obviously depending on the wind, the shape is different, because only these parts that are in gray are the ones in which the drone can fly. So this is some applications of the artificial intelligence, or the hybrid artificial intelligence, in some critical systems. Are the three that I just mentioned: the multi-energy, the second one that concerns remote sensing, and the third one that concerns mobility. We are developing this from now to June the next year, and after, in consultation with the government, the agencies in Singapore, we are trying to define a real use case in which we could integrate many demonstrators in order to create an integrated approach and a smart city. And the things that is new here is we can make well, we can make fast. Why? Because we don't need to learn everything. There is a lot of knowledge. The only thing that we need is to manipulate this knowledge, enrich this knowledge, learn the deviations of the reality with respect to this knowledge. And from all this hybrid artificial intelligence, we can manipulate large system of systems in a more accurate way that's well performed by using standard physics-based models or standard data-driven models. So this is all from my side, and this is the end of my presentation. So if you have some questions, we could try to answer your questions. Thank you very much.
Yes, thank you very much, Paco, for your presentation. It was very interesting. Please note that at the end of the presentation, there will be a shorter survey. So if you have any suggestion of topic or any ideas, it will be good also to share with us. In the meantime, so I would like to ask, all the attendees, if you have any question on the presentation, please raise your hand. You can also unmute your mic or ask your question in the chat box as well. Nice. Everybody is shy tonight. Yes.
Hello.
Yes. Hello.
Hi.
Hello,
Munir. This is Munir.
Hey.
Many of
Hi,
you know
Munir.
me anyway. Hello, Paco.
Hello, Munir.
Like to congratulate. Yeah, it's a great program. It's very impressive, and I see the use case. I mean, it's very, very interesting. And I'm very pleased for your. I have tried in the past; it was very difficult, but you've been successful. So this is very good. I just wanted to ask you, Paco, is in the use cases you presented, you mentioned some of the topics. Do you think that urban health is something which might be of your interest? Like for health prevention in terms of chronic disease, and because we might be interested in using your AI system.
Yeah, the response is the hybrid AI that we are developing is quite agnostic and very general in the sense that even when you are working about handicap, when you are working about health, or when you are working about social movement, people, flows, etc., all these, there are models, obviously, but it's very difficult because these models are too deterministic, even when we express them in a stochastic way.
Yes.
And finally, the idea is the models is better when you have not a lot of data, trying to use the models as first approximation in order to planify, in order to organize, in order to structure something. And after, the important thing, and this is very important, is you need some data that you are collecting in the real place, in the real time, and you are trying to, with this data, trying to correct, not trying to make a model, but trying to correct the predictions that you obtain with your first model. So finally, you can apply this in any scenario, in which, when you are trying to define it, to treat it, or to design it, you have a first approximation about, sometimes it's not equations of physics. There are some rules that you are applying in order to make something. You have rules, but sometimes the rules, you can apply them. These rules has plenty of sense and plenty of logics, but obviously the rules is something that is occurring maybe if the people are acting in a very particular way. For example, it's very difficult to know what is the behavior of the people in a crisis. And in that case, you can assume that in the case of a crisis, there is a fire, there is an explosion, there is pollution. You can imagine that the people is making something, but the reality is not evident. So in order to planify, you try to planify with your logics, and after you try to correct with the data.
But one issue we have with the data is that we are collecting data from IoT devices, and from also open data like urban data, air quality data, and this kind of things. And this kind of data specifically for IoT is not clear data, or it's quite dirty. So I don't know if you are able to handle this kind of data, which sometimes
exactly.
We have many problems with that.
I totally agree. In one of the applications that we are trying also to develop in DesCartes, that is related to the pollution and the air quality. In this case, I agree with you. It's difficult in order, if you have a peak of pollution, what is the data that you need to collect, and where collect this data? For that reason, today, more than trying to put many sensors in many places, that finally you have too much. And second, maybe in the places that you are putting the sensors are not the most indicated in order to take a decision. Our idea is, if there is a pollution, a peak of pollution, and we identify that there is an accident in the harbor, I don't know, imagine that there is a ship and there is some problems. The idea is, for example, you can take a drone and you can planify what is the best trajectory of the drone for collecting the right data in the right place. So finally, the trajectory of the drone is created with a model, because you need a model. If there is the wind that is moving in this sense and the peak of the pollution is in this place, you can imagine that there is an idea about the region in which the pollution is moving. You would like to be sure. The idea is you take a drone and you try with the drone to create the optimal trajectory in order to collecting the best data in the best place. So finally, by using only data in the classical sense, I think this is not a good idea. We have Internet of Things. This is very positive. We can collect data. This is very positive, but we need to collect the good data. And the quantity and quality of the data depends on the use that we are trying to, we are expecting. And for that reason, data is nothing. Data is something that we need to associate with the target. If the target is providing the map of the pollution due to a certain accident, you need to collect maybe few data, but as you mentioned, good quality data in the places that allows you to make a right prediction. So data is a part of the equation. And this is very important for us. There is not something that is the data and after we start making things. No, data should be treated like a component of the problem. What data, where and when is related to the use that we are looking for, and this should be integrated in the process. Data collection, what data, what quality of the data, where and when collecting this data in order to make a prediction of this type, all this is part of the same problem. We cannot isolate data from one side, putting 3 million of sensors around Singapore, and after trying to make things with these sensors, has not sense.
Yes.
We need to adapt the data to the applications that we are looking for.
Thank you. Thank you, Paco.
Thank you very much, Munir. Thank you very much.
We have some questions in the chat, Paco, if you want to read it.
Yes.
We have a question from Arnaud Lyotin.
Okay. Very interesting presentations. A few small questions. Is possible for private companies in Singapore contribute? Absolutely, yes. Please contact Dominic, because we are looking precisely by contributors that are coming from industries in Singapore. At this moment, it was easy for us starting with French companies that are in Singapore, but we are looking for users that could be in Singapore. Don't hesitate to contact Dominic for that point. A more technical question, what is the software architecture that you are using? We are creating ourselves. We have software. In general, we are trying to use open access software as when possible. All the ones that you check in our presentation is OpenFOAM, for example, or that is open access. We are using model order reduction, but we are creating this. We are using open access libraries for the artificial intelligence. And our idea is creating this builder that I presented before, that is able to create applications, data-driven, dynamic data-driven application system in an open access way. So we are trying to create things from scratch. Others, we are taking things that exist, and we are trying to use all the things that are open access, because we would like to use this in the most general and democratic way.
Great. Yeah. Thank you. Also, Dominic put his email address also in the chat box. Thank you. I'm just wondering, is there other question also? We have 5 minutes. It's why if we have any question to ask to Dominic or to Paco as well.
And obviously you can send, if the question arrives a little bit later, don't hesitate to send a mail to us. We will respond.
Yes, thanks. Yeah. I think, yeah, I don't see any more questions coming, but I would like to thank you again for the presentation tonight. We will share, the small survey. It will be good if you can give us your feedback, also some suggestion of any topic that you would like to hear from the next AfterLab. We plan to do one maybe in April or May. So if you have any question, or if you would like to join also as well as speaker, you are welcome also to write to us as well. Thank you again, Paco. Thank you, Dominic, again, and thank you all CNRS team and Ambassade de France team for this webinar tonight. I would like to thank you all for your presence, and have a good evening, everyone. Thank you.
Thank you very much.
Thank you.
Thank you.
Thank you very much.
Thank you. Bye.
Bye-bye.
Bye-bye.